Hey, we're going to do whiteboard problem 10.7. We have a scrawny 20 kilogram wily coyote is shot straight up from a cannon with an initial velocity 50 meters per second. Suppose 20% of the initial kinetic energy were lost due to friction to air. Okay, 20% lost. What is the maximum height wily coyote could reach? Okay, so I just started making the list of givens as we were reading the problem. So let's draw our picture, right, our sketch of what's happening. So we have a cannon, and here's our coyote. Okay, so he's going to have some initial velocity here, and I'm just going to say right at the edge of the cannon, when he's moving at that speed, that's where I'm going to say y is 0. It's going to go up and have some final height here, right? Just tail, I don't want to forget tail. And here at the top, my v final is 0, right? And we'll have at some y final. Okay, makes perfect sense, right? So let's do our energy bar charts. Oh, and we want to find, sorry, forgot to put that, what our final height will be. So our energy bar charts. Okay, so initially, we are going to have some kinetic energy because the coyote's moving pretty fast. We're going to keep track of gravitational potential energy. And then on the other side, we want to, again, we'll just repeat our kinetic energy and our gravitational final. And then we have some amount of energy that is lost due to friction, delta E thermal. Okay, so let's say we have 2 bars of kinetic here, and then we have nothing of gravitational potential, because I said I'm starting at a height of y equals 0. At the end, so we know that we're losing 20%, so that's 1/5, which is not a very convenient split here. That's a quarter. So I don't know, something like that is leaving us in thermal energy. And the rest of it is going to be in gravitational potential energy. Okay. And this is equal to, let's say, 0.2 kinetic initial, right? 20% got lost. Okay, so our conservation of energy equation is going to be that, so let's, I guess, bring these down. Ki initial potential energy equals final kinetic, final potential, and delta E thermal. We'll get rid of the ones that we know are 0. Initial potential energy, final kinetic are going to be 0. And this now we can rewrite, right, as 0.2 times the initial kinetic energy equals kinetic initial. So if we subtract this now from the other side, we have 0.8 times our initial kinetic energy is our final potential. So now we can kind of expand out into our formula. So 0.8, 1/2 mv initial squared equals mg y final. So we have a mass on each side. We can cancel those out. And we want to solve for y final. So I'm just going to move y final over here. I'm going to divide both sides by g. So equals 0.8, right, times 1/2, which is 0.5, v initial squared over g. And 0.8 times 0.5 is 0.4, right? So let's get our calculators out, and then we have v initial is 50 meters per second. 8 times 0.5, right? We're just going to rewrite that as 0.4. V initial is 50 meters per second. That is cruising, and we're dividing by acceleration of gravity, 9.8 meters per second squared. So we have 0.4 times 50 squared divided by 9.8. Whew, that's pretty high. It's crazy Coyote. It's going to go up 102 meters. Be careful. Okay, again, let's review our presentation points. We have our given and find, so that's nice. Clearly labeled. We have a sketch of what's happening, right? Before and after. We have our energy bar chart showing where the energy is initially, where it is finally. We have our conservation of energy equation. We are doing our algebra first to solve for y final, and then plugging in, keeping track of our units, and boxing our answer. Looks nice, doesn't it? I think so.